Well, it's a rather nice day. If only the same could be said for my electric bike. And I'll show you why. You might not be able to see it, but because of me pedalling, the side of the hub motor has actually been damaged. It's almost completely sheared off. It's like it's come away and now the oil's leaking out the motor. It's all cracked right around the middle. I'll try and get a better view of that. You probably can't see it, but it is damaged, and that's not because of the thousands of watts I've been putting through it. Ironically, it's the torque of me pedalling that's damaged the motor, and as you can see, the oil's just coming right out of it. So I'm going to have to give up the power and put this motor on it, which is, I'm sure it's in here somewhere. I've got a different motor. So here's the wheel I'm going to have to put on it now. It's not particularly powerful. It could take a peak power of 1000 watts and maybe only 500 watts continuous. It is filled with oil, so this is going to have to do. So I'll get this hub taken off and I'll give you a better look at it. Yes, as you can see, it's plainly obvious. It's actually cracked the metal almost right the way around. And if that had failed completely, the back wheel would have probably locked up while I was going along the road, which wouldn't necessarily have resulted in a crash, but an unexpected sudden stop. This motor here actually seems a bit more sturdier. I'm just not going to have to pedal as hard, I think. So I'm going to take it apart because I think it's quite low in oil, and I'll just have a look at the oil inside. Because normally the oil should be dripping out the bottom when I turn it on its side, but I don't seem to be anything in it. So here's the motor core and planetary gears, and there was hardly any oil left in it. I think some little fragments of metal, but everything is still in brilliant condition. So just because of the automatic transmission fluid, it seems to really help. I can't see any sign of wear on that at all. So everything seems pretty good. So all I'll do is maybe actually put an oil filling hole on it, just drill a hole in the side and tap a thread into it, but that's all that was left, so there wasn't really much oil. And another good reason to fill them with oil is that it helps to prevent corrosion, because water always does get into the side axles, but because of the addition of oil, it seems to have caused no problems, and everything is in brilliant condition. I don't know about the inside of that thing. I'll take it apart and have a look. And just arrived is another hub motor, which will be going on my folding bike. So I'll open this up and give you a look at that. There we go, that's only about 80 quid, 70 or 80 quid I think, and that's a really good price. And the way you tell whether they're geared or not is that they should be easy to turn one way but difficult to turn the other. See, it turns easily that way and I could barely turn it the other way, so it's obviously geared. I've just kind of got it chucked on a 44.4 volt battery here, just connected up like this. It seems that the controller's not driving it right, because it seems to be jittering a lot, not spinning very fast. So it must be something to do with the learning wires. Oh god, the wires are getting really hot, so it's definitely not been driven right. Right, we'll have a better look at that. Well, I have to say I've never seen anything like it. The cap seems to screw on the end. It was a nightmare to disassemble. It's actually an in-runner. it's actually the magnets on this that spins. It's got a rotor inside. It's looks like an induction motor, but it's obviously not. It's a permanent magnet motor. But yeah, it's a very unusual design. This, I've never seen that before in a hub motor. See this one here. The magnets are on the outside of the rotor. Well, no, the magnets are out on the outside. The coils and the outside can spin round, but this is the exact opposite. And it was giving off a heck of a heat. It just doesn't seem to run efficiently. I'm not sure why. Yes. It's drawn a bit much power under load, about 70 watts. Right, but under load earlier it was actually drawing 300 watts. No, under no load, sorry, it was pulling 300 watts. Oh, that's it pulling 300. So it's one of these wires you've got to connect it together and it changes the way it drives the motor. So right, I'll plug this one in. Right, and I think the other one's cruise control, so I'll get rid of that. Let's have a look. Yeah, it's no great. It's pulling like 80 watts under no load at 48 volts, but it's a lot better. I don't think the wires are getting roasting at all, so aye, that's fine. So I'm going to put it back together, but as I said, it's a very unusual design. Brushless in-runner motor driving planetaries. I've never seen it before, but that'll be definitely getting filled with oil, because I'll be running at a higher voltage and I'll be needing the cooling. Right, so I'm going to take it down to Spokes and get them to build a wheel on it for me. Well, the Hylamar blue's all finished with. That's what you'd normally seal the ends up with. You just put a thin film of Hylamar on each side and then sandwich them together, and that seals them really well. But I need to get more of it. I'll see if the current layer works, and then I'll fill it with oil. And that's a hole that I've threaded where I could fill it through.